So this is going to take me 30 minutes. This is LCA question, right? And over here we will be learning two types, type 1 and type 2, and you will see. And these two questions are from Euler tour only, and segment tree will be included. So I hope you guys know what segment tree is. And basically only one type of Euler tour is applicable in both of these questions, and the other type can be used for this one, right? So this is what I have planned for today. Also, Euler tour is also known as the tree flattening technique, because you flatten a tree to, like, you flatten a hierarchical data structure to a linear data structure. So that's why it's known as tree flattening, right? Anyways, we will get started with Euler tour. So first of all, okay, we have the attendance now. Great. First of all, my voice is clear and everything clear, right? You are able to hear me and see what I'm writing. Final confirmation, and then we'll just start running. Okay. I'm not rushing. I just don't want to waste the time. I will take time to explain you each and everything and solve your doubts if you have any, right? So Euler tour. So basically, without defining any type, first of all, I want to say what Euler tour is. So basically, Euler tour is the what I'll say, the path traced by the DFS. That's what Euler tour is, right? So I'll just start with type 1 only. So let's say that, okay, 1, let me draw a tree first. 1, 2, 3, 4, and 5, and 6, right? So how will DFS start? I will always start the DFS from 1. So my DFS is here. Now it goes here, then 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 it goes here, and it exists, right? So I just am what doing is, I will write the index of nodes visited in the DFS. So how will my flat tree will look like? My flat tree will, first I'm at 2, then I go 1, first I'm at 1, then I go at 2, then I again go at 1, then I again go at 3, then I again go at 5, then I go at 3, then 6, then 3, then 1, then 4, and then 1. So this is the flat tree. Everybody understood how I wrote this flat tree? It's simple, right? DFS order. But did we do that thing, in time out time thing? We did, right? In time out time thing in the first class, right? So it is quite similar to that, not 100%, but quite similar to, right? So I believe this is the order that we are getting. So let's say this is the type 1 Euler tour. Basically, Euler tour I already defined is the what I'll say, basically a flat representation of a tree in the order of DFS, right? So we start with 1, and you can say that, okay, you can see that, okay, we have multiple number of occurrences of of each node, right? So what we can do now is, can we write the code for this, right? We just have to tweak the DFS and we can have this tree. So can we write the code for this? You might be wondering what is the use of this. I will tell you the use of this in just a minute after writing the code. Or maybe let's do the use first, right? Then we'll do the code. Okay. So this type of DFS, yes, that's easy. This type of the flat tree is generally used for LCA purpose. So suppose if I want you to give me what is LCA of 5,4, right? We know it is 1, but how can you get from the flat tree? If you are given this as the tree, then how can you get that? Any idea? Any idea? It's simple if you try to observe.
Can you repeat the question?
What?
Can you repeat the question?
Question is, you are given two nodes, 5 and 4. How can you get the LCA, which is lowest common ancestor of these two nodes in this tree, and provided you have to use this flat tree. Smallest node. Sorry,
I said I understood.
you're not audible properly. Can you
I
close?
understood the problem.
Okay. All right. A smallest node between 5 and 4. Where? And what do you mean by smallest? Omkar, can you have? Can we have your answer? Smallest level. Yes, exactly. So you go to first occurrence of 5. You go to first occurrence of 4. Right? You have a range now. Right? And if you see that, okay, see my pen. Just see my pen. Sorry. Okay. I'm drawing the DFS, not drawing DFS, right? Now I will change the color. Do you get something? If I take the DFS, if I take the DFS from my one node to the other node, this orange is the DFS from one node to the other node. Don't you think that the one with the smallest level is going to in between this in this orange line, the one with the smallest level is going to be the LCA if you think logically. Can we say that? Right? It's pretty intuitive, I think. From the figure you can see, right? So you have a range. First occurrence of this, okay. By the way, you can have many occurrences. So you can store a map, or map may be stored, or maybe a hash array will be stored, and which will have the first occurrence of each and every, like each and every node. It will have the index of the flat tree, right? Where this this node is occurring for the first time, right? So you will have L, you will have R, you know segment tree. You can find out the minimum, like just generate the level tree of the flat tree. So level of 1 is suppose 0, then level of 2 is 1, then level of 1 is 0, then level of 3 is 1, then level of 5 is 2, then level of 3 is 1, then 6 is 2, then 3 is 1, then 1 is 0, then 4 is 1, then 1 is 0. In this range you will have to find the minimum the minimum level, which is this, and this correspond and you will get the index corresponding to this. You will get the LCA. Got it? Segment tree plus tree flattening. This was the use of type 1 Euler tool. Got it. Can we be quick? Yes, or in writing, yes or no? Any doubt you can ask. Otherwise we'll move to code and then we'll move to second. Sparse table से भी minimum निकल. Yeah, you can use any range query data structure. I am a fan of segment tree, so I use that. Okay, so let's move on to the code. What if it's not leaf? No. If you see that, okay, if you believe that it is coming because of the leaf node, no. Let me draw a better tree for you. So suppose this and this, or maybe this, right? Let me draw that DFS again. Or maybe I'll just draw the from here. So it goes here, comes here, goes here. From here it goes up, goes up, goes up, goes. So if we are finding DFS between LCA between 4 and 5, see this is the path. And again the guy with the lowest level is LCA. Right? I think it's very like you just have to draw some examples to get satisfied with this approach. There's no other way. I tried my best to visualize you, but it's up to you how, like, if you can draw some trees and do this, do the thing that I'm doing, you will get satisfied, don't worry, right? So try to do a lot of trees at home and uh, try to do this approach that I'm doing, right? So let's write the code. Okay, so what we are going to do is, first of all, I'll take an input int and scene and vector int adjacency of size n plus 1, and then for int I is 0, I less than n minus 1, I plus plus int uv scene uv adjacency of u dot pbv and adjacency of v dot pbu. pb is pushback again, once again, right? Then what you can do is you will have to design a DFS, right? So void DFS, and what I'll do just for ease, I'll keep two vectors, one flat tree, or maybe let's name it flat only, and one vector int hash, or maybe map hash, map int hash, or maybe let's name it empty only, right? And void DFS int node int parent vector int adjacency, and what else? I don't think anything else is needed. So now what we will do is, whenever we are entering, we will say that okay, flat dot pushback node if, and we'll check that if mp dot find node is mp dot end. If mp dot find node is mp dot end, which means that we don't have it inside the mp, so mp of node is equal to idx. We have to maintain this idx also. So int idx is 0, and whenever we are pushing back, idx plus plus, right? Or maybe idx plus plus. Fine. What if, okay, what if there are multiple occurrences? Just take the first occurrence, and what we have, bro, if you insert, okay, this is what I believe comfortable. Sir, I just joined. Can you tell me what you have covered? We are just doing type 1 Euler tour, and we did try to find LCA from it. First occurrence. Always take the first occurrence. Okay. So now, whenever we are at a node, whenever we are going inside that thing, it will get transferred. But whenever we are leaving that thing, okay, let me think how we are going to do that. I have to visualize myself to code. Okay. Suppose this is the tree. Whenever we are over here, we just index push back. Okay, suppose this is 1, 2, 3, 4, 5, 6. We push this back. Okay. Then we are. Wait. Let me first of all code this. Then if I have time, then I'll explain. Otherwise, you can watch the recording, right? Just let me code this first. Okay. First we are at here, so 1 pushed in. Then we go to this. We call this 2 pushed in. We don't have anything. So whenever we went to that thing, okay, we are saying push back. Okay, so which means that whenever for auto it in adjacency of node, if it is parent, then continue. Then we'll call DFS. DFS of node is it node adjacency. And what we'll say that, okay, this thing can happen. Let's see if we are getting a correct one, right? Okay, let's call the DFS 1, 0 adjacency, and debug flat, and let's draw a tree. Okay, so let's say that okay, we have 6 nodes, 1 2 1 2 1 3 1 4 1 2 1 3 1 4. Okay, what was the tree that we initially took? 1 2 1 3 1 4 3 5 3 6 3 5 3 6, right? Let's see if this is okay. 1 2 3 5 3. Okay, I think 1 2 1 3 5 3 6 3 1 4 1. Okay, we are getting this. Okay, which means that whenever we are all right, see what I did is whenever we are arriving at a node, we first push this back. Whenever we are leaving a node, whenever we ended the DFS, we just okay, suppose we are at the suppose we ended DFS for 2. So after DFS call of 2 is ended, we will be over somewhere over here, right? So what I'll say that okay, whenever we are over here, we just print the node once more. Got it? Or do I have to repeat? Did you guys got how I like why am I doing this? Hello, can anybody reply? Yes or no, anything? इतना लेट क्यों लगा यार रिप्लाई करने में? नहीं आ रहा समझ? You can tell me. If you are not able to understand, you can tell me. What IDX is index of flat tree basically. I just kept this thing to maintain this map, nothing else. Okay, let me show you the map as well. Let me check that if the map is also correct or not. Map is holding basically first occurrence of each and every index of first occurrence of each and every node. So 1 is at 0, 2 is at 1, okay, 3 is at 3, 0 1 2 3, 4 is at 9, 0 1 2 3 4 5 6 7 8 9, brilliant. 5 is at 4, 0 1 2 3 4, brilliant. 1 1 2 3 4 5 and 6, brilliant. Okay, so map is also yeah, we can fill the map with flat tree later on. Basically map is storing the first occurrence, the index of first occurrence of each and every node in the flat tree. And why is that useful? Because I have to, because suppose you are given A and B as LCA, A and B, we have given A and B to find LCA between, and so we will get the first occurrence of A, we will get the first occurrence of B index, and from this index to this index we will do a segment tree query. From this index to this index we will do a segment tree query for the level, and we'll get the index with minimum level, right? Whenever we get the index with minimum level, we will go to the flat tree and we'll get the LCA from there. Got it? Yeah, of course we can fill the map with the help of flat tree later on after covering the DFS. I'm just saving some time right over here. So is this thing clear? Now everything I have explained, I think. Now you have generated this flat tree and map. You can do a while q minus minus and you can generate the segment tree. You know segment tree, right? Equally good to me, right? So you can do it yourself. Wait, do I need to code the segment tree part, or it is very simple? It is very simple, I think. Right? You try to do it yourself. If you feel like I have to write the code, then you can tell me. We can do it in next class, or you can ask any mentor. You are free to ask any mentor, right? Just try to write it. Don't leave it as it is. Yeah, you need to maintain a array of levels as well. You will have to create a array corresponding to this flat tree where you will be storing levels. This array, to be precise, this array that I drew here is also to be considered, is also to be created, right? Exactly. All right, so are we done with this question, or do we have any more doubts? I'm not rushing, right? Or am I? So tell me, what is the time complexity? For generating this flat tree and everything, time complexity is going to be order of n for, and per query. We are doing a binary search, so sorry, a segment tree query. So the time complexity is going to be order of n for DFS call plus order of q into log n for and v plus e to be precise, but of course it is log n only, log v plus e, but you know it, this, right? So it will be somewhat n log n, so acceptable, right? We won't get any TLE, right? All right, okay, so this was type 1 and this was the end of type 1, right? I don't have any more question on type 1, but you can, of course, you can search code forces and you will get many questions where you can solve this, right? Let's move on to type 2. Type 2. And what is type 2? Basically, suppose, let me draw the tree once again. 1, 2, 3, 4, 5, 6. So this is the tree. Again, what Euler tour is same, right? Just the method of creating the flat tree will be different, right? So suppose again I entered the node, right? 1. Okay, you will get to know. You will get to know yourself. 1, right? Then we go over here 2. Then we go over here 1, but we won't paste 1 over here, right? We go over 3, we go over 5, we go over 6. Now, okay, sorry, my bad. We go over 5. Okay, let me start it again. I think I messed up. We are over here 1, we go into 2. Now DFS of 2A has ended, so let's print 2 once again, right? Because we are leaving 2. Okay, now 1 we are not leaving 1, yes, right? So now we are entering 3, we are entering 5, we are leaving 5, we are entering 6, we are leaving 6, we are leaving 3. Now we are entering 4, we are leaving 4, then we are leaving 1. So this will be the other flat tree. Did you guys get what I did? Right? Entering in 1, 1, entering in 2, 2, leaving 2, 2, entering in 3, 3, entering in 5, 5, leaving 5, 5, entering in 6, 6, leaving 6, 6, leaving 3, 3, entering in 4, 4, leaving 4, 4, leaving 1, 1. Got it? So this was the type 2. What is the basically speciality of this type 2? No. Not talking about time complexity, efficiency. How can we use it? There's a one word that I taught you in first class. There's a one word thing. You have 2 occurrences. Between that 2 occurrences, what is there? Between 2 occurrences of, yeah, exactly, subtree. If you try to see 3 and 3, what is this? This is complete subtree of node 3. If you try to see 1 and 1, this is complete subtree of node 1, right? So don't you think that it will be very beneficial in case of dealing with problems such as subtrees, right? So now I will tell you, I will give you 2 questions. Okay, so this is done, right? Let's do let's quickly run a code for this flat tree, and then we'll do a couple of questions to get to know the use case of type 2. What we'll say type 2 Euler tour, right? So what is left? Everything. Okay, we don't require map, so we can, and we don't even require index. We just have to create the flat tree. So it is simple. It is very simple. You don't have to do anything. Whenever you are entering, I wrote the comments that day only, entering the node and leaving the node, right? So whenever you are entering the node, push back, and whenever you are leaving the node, push back it once again, right? And let's do one more thing. Let's keep the index as well, and let's keep vector of pair of uh, what can we keep? Let's keep a map only. Map of int comma pair of int int. I'll do what this map do. I'll tell what this map do. Right. Whenever we are entering, what I'll say that okay, I okay, MP of node dot first is equal to idx plus plus, right? And let's do that thing over here as well. MP of node dot second is equal to idx. Okay, so this is done, right? Just forget about this map thing and index thing. Just see the flat tree. Okay, let's run this. See, 122 122 355 66 122 355 66 3441 3441, right? So this is how we are getting. It is simple, right? It is simpler than the first type, writing the code, of course. So is this thing clear? The code part is clear, right? We are entering the node, so we push back. We are leaving the node, so we again push back. Very simple. Can you tell space complexity for type 1 Euler tour? V plus E. V plus E is going to be the space complexity, or maybe it's multiple, but it is going to be order of n, right? Order of n only. V plus E is going to be the space complexity, I believe. 1, 2, 3, 4, like 2n minus 1. So twice of n, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Exactly. 2n minus 1 is going to be the space complexity, right? So order of n it is. Order of n it is. Right. So this was the type 2. Let's do a couple of questions on type 2 then. So this is one of the questions I'll, okay. In the chat, or you can read from here as well. Okay, you have 2 minutes to think. All right, let's see what you got. What if value of node is not distinct? No, you can use index as the as that thing, right? Index as the value of node, and then you can. I'll explain what we can do. Don't worry. We have one solution. Can we can use segment tree and subtree index map? Huh? To be precise, that is what we are going to do. But did you guys get anything like we have to do the work on subtree, and we have to update as well, right? So update, which means we need to do something related to the range queries, and subtree means we will do something with type 2 of the Euler 2, right? Because we can easily get subtree from there, right? So first I'll clear what we can do is, okay, wait, if you see see this last line, what I'm doing is I'm creating a variable. I will be naming the nodes from 1 to n, right? But I will be keeping their value in a separate vector, right? So whenever I need the value for suppose 3, so I'll go to this array and say that, okay, give me the value of 3. So I don't, in that case, I don't have to worry about that being distinct or not distinct. Got it, Rishi? Okay, great. Okay, so yeah, solution, anything? We will be using segment tree and we will be using subtree index map. But how? How are we going to do that? Let's draw the tree first. 1 2 1 3 3 4 1 2 1 3 3 4 3 5 2 3 3 5. Eh? Okay, okay, okay. Sorry. And we q is equal to 3. We are having type 2. Where we have to get 3 1 5 3 and 2 3, right? Great. So this is the tree. All right. What it is saying that your task is to first of all, you will be given a rooted tree uh, consisting of n nodes. The nodes are numbered from 1 to n, and node 1 is the root. Each node has a value. Your task is to process the following type of queries: change the value of node s to x, right? And change the value of node s to x. Calculate the sum of values in the subtree of node s. Okay, right? So you will be given two types of queries. One, you will be given three integers, right? 1 5 3 is an example, which one means you have to change the value of 5 to 3, right? You have to change the value of node with index 5 to 3. So what you will do, you will go in this array and do an ARR 5 is equal to 3, right? That's what you have to do. And then 2 3 means you have to give the sum of values in the subtree of 3, right? Let's be quick and let's first of all generate the flat tree of this. So my flat tree will look something like flat 1 2 2 3 4 4 5 5 3 1 10. Okay, so is this thing clear? 5 into 2 10. 10 is going to be yes, right? So is this flat tree clear? Can anybody confirm? Fine. All right. What we are going to do, let's try to do the query. We are given that, okay, get me the value of 2 to 3, like give me the sum of the nodes in subtree of 3. So, and the value, let me write the value as well. So 4 is value of index at 1, 2 is value 5 for 3, 2 for 4, and 5 1 for 5, right? So what we are going to do is we need to get the sum of this 5 plus 2 plus 1. Basically, this is what we need to get as sum. So 5 plus 2 plus 1, which is 8. That should be the answer of first, which is there. Now what we are going to do is we're going to update 5's value as 3, and then we get this again. So 10 is going to be our answer, right? So this is what we have to do. So what we can do is, suppose somehow we generate a segment array over which we will build our segment tree, right? Over which we will build our segment tree. And what I am saying that at the first occurrence, at the first occurrence of every node, we will place its value 4. What is this? 2. So 2 means 2 only. 2 means now we got the second occurrence. We'll say that okay, 0. We don't require any value at the second index. Why? I'll tell you. 3, 5, 4, 2, 4, 0. Or maybe we can do that. Maybe we can provide the value. Depends upon the test case. It depends upon the logic, right? In for the time being, I'm not giving the value in the second occurrence. Yeah. I just realized that we can do the sum up and divide by 2, but I am not planning to do that, right? So that's why I'm using the second index values as 0, right? This is second, this is again second, right? So see what the benefit we are going to get. Suppose we want to go at the subtree of 3, right? We will say that okay, first occurrence of 3 is here, the last occurrence of 3 is here. In this, if I somehow get the sum in this range, 5 plus 2 plus 1, 8. This is my answer. Don't you think? 5 plus 2 plus 1, right? Yes or no, guys? Only 2 people here, 3 people here. If you're listening to me, say yes or no. Come on. Okay. You're understanding, right? What I'm saying. Okay. So now why did we kept the other value 0? Because we know that okay, it might be the case where our node will visit and end the node in the subtree of this, right? So which means that okay, what we can do is we can either keep the second value as that thing only, that value, and we can like get the whole sum and divide it by 2. But I chose to keep the second value as 0 just to give no contribution to the sum, right? So now comes the this was the easy part, right? You build a segment tree upon this array, right? And you will just get the index and you will say that okay, give me the sum in this range, right? Now what you have to do is you have to do something important. How to do this indexing? I'll tell you. Haven't I told you in the code? See, this is the code. Whenever I'm pushing, I'll say index plus plus. Whenever I'm pushing, I'll say index plus plus, and I'm storing that whenever we are pushing it for the first time, mp of node dot first value is going to be this index. And whenever I'm pushing for the last time, I say that okay, mp of node dot second is going to be that index, right? So in this fashion, we will be able to get the first occurrence index and the last occurrence index, right? Got it, Aman? Okay, great. So now what we have to do is we have to update sum at 5, the value at 5 to 3, right? So what we will do is we will get the first occurrence of 5 because we haven't updated the second occurrence of 5, right? Second occurrence of 5 will always have the value 0, right? So we don't have to care about this. We'll go to the first occurrence of 5, which is at index this, right? We will get the index of the flat tree, and that will be the index of segment tree as well. We can go to that and update. We will update this from 5 to 3. Then again we have to do this. So we'll sum this up. So 5 plus 2, 7 plus 3, 10 is what we will get our answer, right? So this was the main logic about this complete problem. Got it? How is updating working? Right? We just have to go to that index, update. That's it. If you are keeping 5 at both the places, like the value at both the places, then you will have to go to update both the places, right? So it will be taking some extra time. That's why I kept it as that's why I kept the second value as 0, right? So do you guys want to get the code? Code is simple. Code is very simple if you know what segment tree and these things are, right? So see here, this CNT is what index. This is your flat tree, of course, and index is a vector of pair that I passed over here. You are free to use a map that I used in the code, and this is how you are whenever you are inserting whenever you are getting inside of a node, you do this. Whenever you are getting out of a node, you do this, right? And you will maintain a segment tree. of, yeah, segment tree for sum, right? And whenever you are over here, uh, index DFS, then visited, then you will create the segment tree array for auto IT in flat. If visited of IT is 1, I created a visited array. If it is 0, that which means that this has been visited for the first time, I'll say that okay, this has been visited for the first time. I push back the value and the value of that particular index, right? And if it is not the first time, then we'll say that okay, push back 0. So in this case, I will be getting a segment tree array of size 2n, right? So that's why, that's what I'm doing. I'm creating a segment tree of size 2n. I'll do the build function for segment tree, and I'll do the query. While cube minus minus, I'll take the type. If type is 2, I'll take the node, input the node, and we'll say that okay, output the answer for, okay, output the answer for this is ind 0, this is L, this is R, and this is, sorry, this is L, index of node dot first occurrence, index of node dot second occurrence, and the segment tree array. And what else? If it is the type 1, we'll take the node, we'll take the value, we'll take both of these, and we'll just update at the first occurrence, right? That's it. That's all we have to do. Encountered, we may encounter, but I haven't. Yeah, I have, I think. Flat tree was useful somewhere, right? So it's, I don't think that this is so difficult to leave the topic. Like for me, my favorite topic is trees, so I just tend to do these things so interestingly. Anyways, was this question clear? You might need Euler tour somewhere. Everybody, can I get a yes from everybody present in the class if you are listening? Okay. All right. So let's move on to next problem then. Next problem will be very similar. So I don't think that I even need to write anything. Let's see. Read this problem. You have the question in the chat. All right, any update? No idea. The trick is very same, very same. Okay, let's do this. We will add second occurrence. Got it. Yes, exactly. That is what I was going to do. See what we are going to do. I'll just update this thing only, right? So it is, I think, the same question. Like the test case is very same. 2, 4, 2, 4, and 1, 3, 2. The queries are different. 2, 4, and 2, 4, and 1, 3, 2. And the tree structure is same. 1, 2, 1, 3, 3, 4, 3, 5, and 2, 4. 1, 2, 1, 3, 3, 4, 2, 3, 5, right? And 4 to 5, 4 to 5, 2, 1. Great. What we have to do is you will be given a rooted tree consisting of n nodes. The nodes are numbered from 1 to n, and the node 1 is the root. Each node has a value. Your task is to process the following types of queries. Change the value of node to s to x and calculate the sum of values on the path from root to node s. So suppose if you are given 4, you will take 4 as a target. You will rush down from root to this 4, and the sum 4 plus 5 plus 2 is your answer, which is 11. Great. This is the answer for the first query, right? So how can you do that? I say that, okay, I will just maintain this type 2 only, type 2 segment tree, this type 2 flat tree. And what we are going to do is whenever we are going to get into the first occurrence, nothing will change. But in the second occurrence, I'll do a minus. I will 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 do a minus. Why? Why are you doing a minus? So let's see that. If you are going to, suppose we are going from root to 4, right? So I will say that, okay, okay, don't worry, we will be going from root to 4. But suppose the first occurrence of 4 is over here, right? So let's get the sum in this and let's see what things are cancelling out. So 4 plus 2 minus 2 plus 5 plus 2, which means that this 2 minus 2 is being cancelled for 2. And why is this being cancelled? Because we entered inside 2 and got outside 2 in this whole first few iterations only, right? So we entered inside and we got outside, so which means that this is not in the path from root to node, right? Which means that it has to be subtracted out. So it is doing the work, right? So when it disappears, 4 plus 5 is 9 plus 2 is 11, right? That is what you will get our answer. Right now what you will do, you have to update the index at 3 to 2. So what you will go to, you'll go to 3, you'll say that, okay, 5 change to 2, you'll go to second index as well and do a minus 2, right? So and now you want to get for 2 to 4, then again do this sum. 4 plus 2 minus 2, this is cancelled out. 4 plus 2 is 6, 6 plus 2 is 8. 8 is now the new answer, which is this. Very same, but just a little bit change in the thinking, and we were able to solve another question. Got this approach? Did everybody got this approach? Yes or no? Great, 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 great. No code again, because I have already solved. So I'll just show that code only. It is, by the way, very similar to the previous one, right? We will be again maintaining a segment tree. Our flat tree will be done in the same manner. And whenever it is the first visit, push back the value. If it is not the first visit, push back the minus of it, right? And this is where we are doing the query. Take type. If the type is type 2, take the node, scene node, and do a sum from 0 to, from L is going to be 0 and R is going to be the first occurrence, right? Including the first occurrence. Great. And if it is not, then go to the first occurrence update, second occurrence, do a update with minus sign, right? That's it. All right. So this is done. Don't worry, I'll give you both the codes. Right. And let's do this brilliant problem. Okay, by the way, Euler tour is done, right? This is not a Euler tour problem. This is a LCA question, right? By the way, you can do LCA from Euler tour, but Euler tour this was Euler tour. right? So do you guys have complete understanding of Euler rule now? Where to use type 1, where to use type 2? Do you guys have it? Kind of. Okay. Right. I don't expect you to be expert of this in 1 or 1.5 hour. Yeah, type 1 will be mostly used for LC only. It is kind of flex to show in front of others that okay, I have two ways to find LCM. So that's it. Oh, by the way, shall we move on to the next question then? This is a good question, right? This is a good question. You are going to like this one. Okay. As per my plan, I am on my way. Uh, 30 minutes is what I will, what it will take for me to teach you this problem. So shall we begin? This is the problem 1900 rated and already given you the hint LCA, right? So think in that direction. First of all, I will give you complete 3 minutes, right? Or let's take 2 minutes, go through read the question once, then I will explain you the question, then again read the question, and we'll start the solution at 1930, right? I'll give you the link. I know most of you won't understand the question in one go. Read the question or do you guys need some more time? Need time? Or should I start? 1 minute, okay. All right. If you are done reading, let me ask you, did you guys understood the problem or not? Understood? Everybody understood? That's great. That's very great. So let's do the test case only then. Okay. All right. Fine. So what we are going to do is, let's see. We are given a rotatory consisted of the root is at 1 n minus 1 edges, m queries we are given, and ith query consists of the set of ki distinct vertices. Your task is to say if there is a path from root to some vertex u such that each of the given k vertices either belong to this path or has a distance 1 to some vertex on this path, right? So what does this mean? This means that let's draw the first example, right? So let's draw this. This is the first, right? So let me draw it. This is the 4, 7, 8, 9. This is 10, right? So first query is given as, okay, you will be given 6 queries. So first query is given as 4 nodes and 3, 8, 9, 10. 3, 8, 9, and 10. Okay. So where is 3? 3, 8, 9, and 10. So is there a path from root to any node such that either the nodes are on the path or at a distance of 1 from the path, right? So yes should be the answer for this query, right? So this was the question. Did you guys understood this question well? Like this was what you understood, right? If you understood the question correctly, then give me the solution then. If you have, you already acha, now understood correctly, great, right? So let me do the dry run for every query, right? 2, 4, 6. So 2, 4, 6. So this is the path, one distance on the path, right? So yes is the answer. And let me do a one no. 5, 4, 7. 5, 4, 7. So let's take any path. Let's take this. So this is 2 distance. This is 1 distance. 2 distance not valid, right? Let's take this path. 2 distance again not valid. Let's set this again, 2 distance not valid, right? So which means that the answer for the last query is no. Now give me a solution. If you have the hint of else using LCA. Okay, let me give you one more hint. One more hint, right? The hint is first decide which part to take. First decide which part to take. You know one end. You know one end. You know one end. This is one end. Root. Of course, you have to start with root and end somewhere. What is that somewhere? What is that node? If you get that node, it's intuitive that what node will be this. To get that node, you will get the value. You will get the solution. Lowest level. How are you saying that lowest level is that node? How are you saying lowest level? Okay, lowest level is the correct answer, by the way. And I can say that why is lowest level the correct answer? Let's take 3, 8, 9, and 10. So if this is the lowest level, right? My path can go from here to here, right? I can also have this path, and this would also be correct. But just extending it to the lowest level does not makes it wrong, right? We don't have to get the shortest path. We have to just get a path, right? So if there is a lowest level, that has to be included, right? Which means that either we will start from its parent, right, or from itself, right? So let's start from itself, right? This is the first condition. This node is the lowest level node. Got the intuition why lowest level node? Yes, exactly. Because we need to reach till lowest to ensure that most of the nodes are covered. Right. Exactly. Got this? Yes. Lowest level of k these given nodes. Of course. Yes. Yes. Exactly. Now, what is the next step? Next step. Now you got a node, right? You got a node. You just have to check from 1 to 10. Can you do this check? Can you do this check for each and every k nodes given in per query? Now your main logic must be around how to check that the node lies on the path that is selected. If you are able to do that, and of course LCA would be helping you there, you are solved with the, you are done with the question. So just take some time, try. Any idea? Are you thinking? All right, I'm going to expose the solution now. Can I? Or do you need some more time? What should we do? Should I expose the solution or you need time? Time or solution? Okay. See what you are going to do. You find the lowest node. Let's take this example. 3, 8, 9, and 10. LC of the given node with the lowest level node is same as the node, and for second condition we maintain parent. No, no, no. First of your part is correct. Second of your part, like the thinking is correct, but of course you are not implementing it properly, right? So these are the 8 nodes. You have this lowest node, right? Every time you encounter a node, right? Suppose these are the 4 nodes, right? Just you keep count on this node. You have this node, the node with the lowest level, and 4 nodes, right? You will iterate in this node, say that okay, 3, what is the LC of 3 and 8? What is the LC of 3 and 10, right? So this is the LC of 3 and 10, right? 3 and 10, of course, right? And if this is, and all right, now we have the lowest level and we know this is the lowest level, which means that this is going to be at a higher level. So LCA of 3, right, or basically LCA of node I comma node, this node I is the nodes in this query, and node is what, the lowest node, right, minus, and this what level of this, Just basically what I'm trying to say is we just have to get the LCA with this node. So its LCA is 3, right? And the node itself is 3. So if they are equal, which means that they lie on this node lie on the path. So okay, this is done, right? We go to 8. 8 and 10's LCA is going to be 7, right? So what I'm going to do is I'm going to check that okay, 7 and 8's difference in the level. If it is less than or equal to 1, then we are good. But if it is greater than 2, then it does not follows our rule, right? So if LCA's level difference with the node is less than equal to 1, then we are good to go. And if it is not, then it is not. So if the difference between LCA's and the node's level is 1, right? So it is also acceptable. The next node is this 9. 9 and 10's LCA is 9 again. So it again, the difference is 0, it is acceptable. Again, same for 10. 10 and 10 LCA's is 10, right? And of course, they are on the same path or maybe one above. Just consider level. Why we took the lowest node? Now you can also say that okay, with the lowest node we can have that LCA relation, type relation, right? Got it? Now got it? Got it, everybody? Wanna see code? Wanna see how I coded this thing back in Feb 2022? 1 year, sorry. See, this is you have this you have with yourself, right? We did it together in the last class. This you have already. This you have already, right? NM took the tree, made the DP thing, also generated the level, called the DFS. Now per query, we are going to solve this, right? K, scene K, take the maintain an array of size K, max level minus E, a node, arbitrary node 0. That I am fan of taking that. And for the K, took the input and just using this if condition, after the loop ended, I have the nodes index and its level, right? So I just check this. This is nothing. This is of not relevance. Then bool flag is false. And what I'm going to do is I'll do the iteration on K and check the LCA of node. This node is what? The max level node. And this ARRI is the current node, right? And I get the LCA of them, right? And I'll check that if the LCA of, if the difference of level of this temp node, which is the LCA node, and the current node, if this is greater than 1, then we'll say that okay, print no, flag is true and break. And if we broke out of this loop, and if the flag is true, we have already printed answer for this query, right? Then we'll continue, right? And if the flag is not true, which means that okay, we never ended up in this block, which means all of the nodes are valid, which means that we are not going to go inside this, and we just print yes, and that's it. Wasn't it simple? Right? I know it was not simple, but now it's simple, right? Interesting, exactly. Last level part is confusing. You just have to like be obvious. If you're going to cover the last node, you have to either take it, or the other way of doing it is just keep the node till its parent, right? The path is like this, and this is directly joining. This is the darkest level node. Now, why is this going over deepest level node? Sorry, right? Why is this going here over here when the deepest level is there? So don't you think that the path should be here, right? So it's just about intuition, right? These things will get strong with practice, right? The intuitions will get strong with practice. All right. Then we solved 3 problems, and we learned 2 types of Euler in this class. Everything is done till now. We are just left with one tree class, which is on DP on trees. Such as these kind of problems, I'll give it them in daily tasks. I'll try to give them in daily tasks, right? Your daily task will be from Monday to Friday, right? I have to update them tonight. Bye. All right. All right, then I'll share these notes with you. Notes, sorry, ज़्यादा tree पढ़ा लिया, notes बोल रहा हूँ. Anyways, I'll share these notes with you, and then I think either on Wednesday, Thursday, any day we'll meet, right? For the last class, which is on rerouting and deviant trees, right? The last class on trees, then we will be starting a new topic, or any other mentor, any other tutor will be teaching you the new topic, right? Wait. All right, one more thing. Wait, don't leave, don't leave. The review form. This is important. This is the review form. Please fill this if you can. Let me check if this is the correct one. Level 4 trees. Yeah. Please fill this, guys. Right then, okay, if you have filled this, you are free to leave. I'll end the class in a minute or two, right? In a minute.